So this is a talk about Android Wear and Google Glass internals. How many here have Android Wear or Google Glass? I should have asked this separately. How many have Google Glass? Okay, and Android Wear. Okay, so a few of you. So I marked this session as intermediate because I know there's always beginners and advanced. So those who are advanced, I promise you'll learn something. Beginners, please bear with me. If I go a little fast, I'll try to be slow in introducing both Android Wear and Google Glass if you haven't seen it before. Right now I'm wearing glass and connected to my laptop. Let's see if we can see it. Alright, so it's this. I'm using the Android screen monitor. That's a screen capture program that runs over ADB on USB. And let me just wake up this device. So, does everyone hear me all right? Okay. So again, welcome. I'm Dario Laverdi. I wear a couple hats. Right now I'm wearing the NYC GDG organizer hat. I also work for HTC as a developer evangelist. I had a talk earlier at 11 about HTC dual lens API. But right now I'm going to be focusing on my personal as an independent developer point of view of Android Wear and Glass. So as you can see there, this is what I'm seeing. I have an app running which I'm going to demo in a little bit. But for those who haven't seen Google Glass, for your benefit, basically it's a heads-up display and it's basically meant for notifications. We have on a timeline, so you can see my chats, you can see settings. And again, bear with me because this screen capture program is very low frame rate. So what I'm seeing is a lot smoother than the choppiness that you're going to be seeing here. And the same goes when I show you Android Wear, when I connect that. So I'm going to be talking about, first some disclaimers, and I already started talking about what I do. So I'm not implying anything by this talk with regards to my employer, HTC. So please don't ask me about, well, what does this mean for HTC? I'm here really as a fan of Google technology right now with Android Wear and Google Glass. So I also want to make a disclaimer that I'm not liable if you break your glass or your Android Wear if you do some of the things I'm going to show you. So it's your responsibility. So what do we mean by internals? Do I mean the actual innards? So right now we're looking at Fixit.com likes to take apart all these new devices all the time as soon as they come out. That's actually the Motorola 360, which I'm wearing here. This next internals photo is the LG watch, which I also have here, which I'm also going to do demos with. And of course, a lot of people have taken apart glass. But is that what I mean by internals? No, what I really mean by internals is software-wise. So as you know, both Android Wear and Google Glass are based on Android, and that's why we're here at this conference. And they're based on the Android open source project, the open source code that a lot of OEMs, together with Google, have access to. There's the public branch, so to speak, and then there's the private one that Google manages. So right here we're seeing a screenshot of Android 4.4W. That's the watch version, release 1. So they've published the AOSP part of that, not all of it, and I'll explain a little more on what's available. But what we're here also to do is to root our devices, and I'll explain why you shouldn't and why you should. And my opinion is that end users shouldn't have to root at all. I think root on some of these third-party custom ROMs by default is a big mistake. In addition to voiding your warranty, you're opening yourself up to security issues, which again are not covered by anyone being responsible you also have potential hazards. I mean, if you overclock the device, it's going to heat up. As it is, many of these devices, even within legal standards, heat up as it is. So imagine overclocking it or making it faster. It's just, I don't think it's a good idea. But I know there's a lot of websites that say, here's the 10 reasons why you should root. You should get this app and that app and this app. In general, I think you should not be convinced that if for each one of those I have an argument. And again, I know some of you at this conference, I know there are some XDA members at this conference, and if they were here, they would probably want to heavily debate me on this. But I'll table that type of debate if you want to debate me till the end of the session. But I want to focus as to why you should root is as developers. There are really good reasons to. And again, only developers. This is only in your own private development workflow. Why? Because it adds debugging facilities. I don't know if you ever noticed that when you run the emulator, it runs as root. So you're able to see all the processes in the DDMS list. And when you plug in a commercial device, you're only stuck seeing your own activities and processes. And that's a limitation. It'd be nice to see how how all the processes are running, be able to profile other APKs and so forth. So there's legitimate reason to root a device for debugging purposes alone. Now, if you have an issue that's serious, that's a showstopper, and you have to wait for Google to fix it, or a specific OEM to fix it, or waiting for a carrier to update to the latest fixed version of Android, you may, this will help you develop workarounds, maybe implement the actual fix so you can get past that issue and continue developing. But of course, my favorite reason is to experiment and to learn, because it allows you to understand under the covers how the framework works at a very, very low level. Now, you don't have to go all the way to the level of C or the VM, just to see the framework, the Android framework classes at work, and how they use system privileges, for example, to do what they do, and why it was designed in that way. To try new UI and input interfaces. So I just showed you the glass experience. It's very different from Android Wear. Now, who knows, down the line they may converge at some point. We don't know. But this is the great time to experiment. So if you're passionate about UI and you want to test some things that you normally are not allowed to because Google has set this in stone, this is the way this UI works in this device, and this is the way you can try to experiment and see, well, maybe we can break the rules and just to see what it looks like. Maybe we can try the timeline that Glass has on Android Wear, or vice versa. Try the card layout and navigation on Android Wear, and maybe try it out on Glass. Maybe there's something that we can learn and explore in doing that. And of course, if you're a hardware tinkerer, you definitely need to root. You want to be able to add a new, customize. You don't care about avoiding your warranty, so you want to cut into it, add a new sensor in it, and so forth. And obviously, you need to write drivers, and you'll need to access the kernel, and that's really low level. But those are the reasons why you should root as a developer, and again, only a developer. And we can argue about whether end users should ever need to later. We all know ADB debugging, because we're all Android developers. We all know that the first thing you have to do is to turn that on so you can connect the USB to your device. Interestingly enough, this doesn't have a USB interface, but we'll talk about it in a second. Ideally, we want to be able to do stuff that we're used to doing at the command line if you're a Linux hacker or a Linux programmer. One of the things people forget that as of, I guess, 4.2 or 4.3, there's a security feature in ADB that you have to authorize the laptop, the host machine that's connecting to the device on the actual device. And that's a security feature because they don't want somebody inadvertently to pick up your device, connect to the laptop, and do something malicious. You have to be authorized to do so. And it makes a lot of sense. Because a lot of people turn debugging on and just keep it on forever. It'll never occur to them. It's a security issue, and then they should turn it off. So that's why Google introduced this thing. And a lot of times, you forget that you have to authorize. I keep switching from device to device. On glass, it's a little tricky, and if you forget, it may not prompt you again, because they're very conservative with what kind of messages go to the prism. So you actually have to toggle ADB on and off every time you want to authorize a new device. So what we want, our goal is to be able to root the device, and to do so, it's almost a chicken and egg situation, because you want to be able to do so by setting up the initialization files that set it to root, but to do so you have to edit those files, and by default the system partition is read-only. So what we want to do is be able to set it to be read and write. So the eventual goal is to write on the boot image, and I'll go into more detail a little later, the ability to toggle the flag that lets it be rootable by ADB. There's a command called ADB root, and to do so you have to actually set it as read-write, and which means you have to actually replace that partition. So I'm going to show you an example. I actually did that with glass, and I'll walk through every step. I just want to mention also for Android Wear, it gets a little tricky with ADB because they give you the ability now to do ADB over Bluetooth. So for those of you who haven't played with Android Wear, in addition to some of the watches that do have a cradle with USB, like the LG, which I'll connect in a little bit here and show you. So it's more convenient from a testing perspective to actually wear it and do ADB through wirelessly. Now in this case you have no choice for the Motorola, but for any of these watches, you want to be able to wear it while testing and running ADB. They've enhanced the ADB forward command to do an abstract hub, so to speak, so you can actually tunnel through your phone to be connected via USB to your laptop, and then you can communicate wirelessly through Bluetooth by running these commands. All right, so we want to go from ADB to fast boot, because it's at fast boot level that you're able to write to partitions and flash the different partitions. And again, for those who are not familiar with the layout of the Linux, not just the Linux kernel, but the layout of the partitions of the device. Generally, there's a bootloader, and there's a kernel that's in a different partition, and there's a system, there's a user data as well. What you want to do is be able to come to the fast boot command, which is a bootloader that's before the actual system loads, that allows you to do those commands, like flash a partition, replace the kernel, and so forth. So generally, on phones, you can hold the power key or the volume down while you're booting to be able to get to the bootloader menu. On these other devices, it's different combinations on the hardware. But as long as you can get to ADB, I always find it easier to do it from the ADB command line. So ADB reboot -bootloader, and you'll get it to reboot into the bootloader mode. If you insist on doing it by buttons and so forth, these are the sequence of commands you have to do on glass to get it into bootloader mode. For the watches, it's actually quite much simpler on the watches. In fact, it could be a little problem, because some people have discovered this feature by mistake, by accident. Like on the Motorola watch, if you're powering up and you hold the button for too long, it'll vibrate once, and then after a few seconds it'll vibrate twice, meaning it's going to go into bootloader mode. And then people were complaining they got into this bootloader mode, and it was by accident. So it should be more difficult to get into bootloader mode. On the LG watch, again, it's very straightforward. As it's booting, if you swipe from the top left to the bottom right, you'll enter the bootloader screen. And generally, what that screen does is give you options to do several things, including restarting and rebooting and powering down. But it'll allow you to show you the status as you're writing partitions, and maybe I'll do a demo just so you can see. So eventually, at the end of this is what you want to do to unlock your device and void your warranty. You want to run fast boot OEM unlock. Now, This generally is the command you do for Nexus type of devices. Google is always insisted that OEMs support this command for their flagship phones that are receiving the stock UI from Google. So for instance, Glass, this works, and so far on all these phones this command should work. I haven't been able to try it on Motorola yet because of lack of USB, but it worked on the LG. And again, you're voiding a warranty, but again, if you're careful on what you're doing, and it should be okay. You can always lock it again. You can also avoid, you can cheat a little bit and avoid voiding the warranty by using some exploit that gives you root access without having to run that fast boot OEM unlock command. This is one that was available for as of Android 4.0.4. It's no longer available. They closed that loop. But basically, if you got Glass when it first came out, which I did, you can obtain roots and consequently be able to flash by running these commands in this order. And what I mean by avoiding warranty, technically you void it as soon as you root it or flash or unlock it to be able to flash. But what this does is it doesn't leave a trace. So generally when you run that command, when you run fastboot OEM unlock, it sets an internal flag saying it's been unlocked. So your warranty is voided. So even though you don't see it, on some phones you actually see tampered on the bootloader. But on these devices so far, there's no way of telling if there's a flag indicating that you've actually voided your warranty. Okay, so a few notes about running this command fastboot OEM unlock on Google Glass. It's completely broken on Mac OS X. There's an issue with the USB drivers and fastboot. So what I had to do was actually unlock this on Windows or Linux, because it works on Linux and Windows. So if you want to actually unlock your Glass, I'm going to save you a lot of time and headaches if you try to insist on doing it on the Mac. It's a known issue. It's been a known issue since last year. The trick, there's something to watch out for on Windows though, and I can't believe I'm doing Microsoft Windows stuff on this slide, but basically if you want to unlock Google Glass, you actually have to modify the USB driver entries that the Android SDK provides, because what you use by default won't work. So you actually have to add 2 lines to this, and then when you install the driver, you point to this file, Android USB .inf, and it'll work so that you can actually do fastboot from Windows. All right, so this is what I did on Windows. Basically, this is what it looks like when you void your warranty, in case you were curious on Google Glass. So I noticed that, let's see, I have to do it twice. Let me look at this. Yeah, so you can see when the device is unlocked, and then you have to reboot it manually. It doesn't reboot automatically. So what does it mean when it's unlocked? So it means that you can actually run commands that flash partitions. So here, what we're seeing here, and now I move back to my Mac because I've unlocked it, so now I can continue running on my Mac. Here I'm booting to the bootloader, so I can run fastboot. And then here's where I flash the boot partition with this boot XC21 rooted image. So where did I get that image? So fortunately, Google does supply a rooted boot image on their website. So once you obtain that, you download that image, you can run fastboot flash boot and the name of the actual boot image. And the next time you reboot, you have the ability to run ADB root. Let me see if that's on the next page. Yeah. Whenever you're in Linux, for those familiar with the command line, if you do ADB shell, you usually get a $, meaning you have user privileges. You're not root. Here I do ADB root, and then when I do ADB shell, you see it's instead of a $, it's a pound. So once I'm in the pound, I am able to do anything that the rooted user can do. So I reboot again, and then I run ADB remount, and you notice that when I reboot, it doesn't stay rooted. And I think that this is a safer mode to operate in. To always have to type ADB roots to get roots, and then run ADB remount to be able to successfully remount the system partition as read-write. So it's all about getting to these two last lines, ADB roots and ADB remounts, to finally have full access to your Google Glass, and now you can actually play around with the system files and the system partition, and make changes to the splash screen, maybe change that command of, okay, glass to something else. So you have all these, and now I'll talk about what ideas we can do later on. One thing to point out is that all the Linux kernels are GPL, so they are required to post the source code for the kernels. So basically, shortly after the release of the device, they are obligated to release the source code for kernels. However, for the Moto 360 now, it's been a couple of weeks now since this, I think this was announced last week, a couple of weeks. I'm still waiting for the kernel source code for Moto 360, so they have to comply with that very shortly. So about Android Wear now, they similar to Glass, they are keeping their cards close to their vest. In other words, they are not releasing everything, so you cannot build a complete build that runs on Android Wear or Glass. They are only releasing what they're required, and it's not just the kernel. Sometimes there's some framework files that are affected by the kernel GPL that are also GPL, and they have to be released. But there's enough there for you to understand and start learning and play around with. So building kernels. Let me go to their website so you can get a quick idea of what you look at their sites. All right, so for Google Glass, they have a dedicated site for system and kernel downloads. So you can get a full factory image, so in case you do mess something up, you can recover to the original to the stock version. Here we have the very latest XE21 for Google Glass, and here's where you download the rooted bootloader. I generally rename that because I want to make it clear that this image is rooted and what version it corresponds to. Going down this page, they give you details on pretty much a lot of what I've already showed you, and they also give you the links to the kernel source code with instructions on how to build. So if you're really going down this road of customizing the kernel, maybe enabling some feature to make it faster or conserve battery better or some flag on some device driver, this is essentially what you need to do. You need to get the Android open source code toolchain so you can compile and build for that architecture, ARM. And you have to check out the right branch. Now, their documentation, and I've already told them this, is incorrect. So they're still posting the branch of the original version of Google Glass instead of the most recent one. And one of the ways I found out about that, let me go back to the command line and actually show you. So I downloaded and installed in this folder the kernel source code for Glass. It just blanked out there. Let me go to my slide because I have it there. Git remote show origin. So when you're building, you have to make sure you're building the right code for the right ROM and right device, because of course you may break your device if you put the wrong build. Or may not even install it or run. You can probably recover by, trying to flash again. But you have to be careful and always double check the actual code. So XRR02 is incorrect. It should be XRW66 for XE21. The way I found that out was by looking at all the branches, and I did that by running git remote show origin. here. You can see how many versions there have been since the first one. It's like over 25. And a lot of these will not necessarily map to a release version. Sometimes they have interim releases that don't get publicized. So that's another thing you have to watch out for as well if you're interested in building kernel source code. So you can see at the bottom here, XRW66, that's the latest that corresponds to XC21 version of Glass. So they have more than 25 here. It's because there were some interim versions when they were really having problems between updates, and they had to like continually make updates, dot updates. All right, let's just move ahead quickly. That was the demo showing that. So I want to like do a little sideline now of an experiment I did before Android Wear was released to the public. Back in March, that's when they first announced Android Wear. They introduced a preview, which was a subset of the final, the ability to run it in an emulator. So I decided, you know, what if I just try to take that and make it work in an actual watch, a smartwatch? So there have already been a number of Android smartwatches in the market for the past year or two. If you just Google it, you'll see dozens. But they're not, you know, they're not Android Wear. They're just running Android as like putting a phone into a watch. It's one of the reasons Android Wear exists, because Google started seeing a proliferation of all these devices and said, wait a minute, we need a standard. We need to standardize this now before it gets out of hand. So back at the DevCon earlier this year, I presented a talk on hacking an Android smartwatch to run Android Wear in 5 minutes. So what I did was I bought this watch. Let me see if I can show you this through Glass, maybe. I'm going to try an experiment right now. So I'm going to try to maybe if I record a video, I'll show the viewfinder, and you can see. I don't know how that looks. So I bought this watch for 99 bucks. It's from China. It runs Android 4.3, and I managed to very easily, almost in 5 minutes, actually it was longer than 5 initially, but I demonstrated how you can port Android Wear to an existing Android Smart watch. Sorry, I'm running this other thing, which I'm going to demo in a second. But to make a long story short, let me just go back to the slides and just... This is what I did. I Googled for a smartwatch. I found one for 99 bucks. I bought it. And I insisted on getting a watch because emulators are not really the way to experience wear. And that's why there's no emulator for Glass. You actually have to purchase the device. You actually wear it and experience it to be able to even develop. Even if you're not a designer, you need to be able to understand what the experience is about. So I really wanted to experience Android Wear on a watch. So I went ahead and did that. It's a funny story about this too, because I posted a video about this, and suddenly Google like freaked out and they thought I was like leaking an Android Wear watch. I had to assure them, no, this is just a side project. I took an Android smartwatch and I made Android Wear run on it. So that's why I picked up this watch. It actually has some features that Android Wear doesn't support. It's got an audio plug, so I can listen to audio, which is, I don't know, it's pretty funny. So I managed to get ADB to work, and I managed to make the system writable, like we were talking about earlier. Fortunately, they were hacker friendly, so a lot of this was a lot easier. And I managed to find the libraries and the APKs that I need to copy into this device. And it was literally that simple. And here it is, a picture of it running an app that scans for beacons using BOE. So I found that was something that's very common with Android Wear and some of these implementations of Android smartwatches before Android Wear was announced. For instance, in both of these cases, they use a standard launcher. So I'm able to toggle between their stock launcher and Android Wear launcher So it's like having both systems available to me. And the other thing I like about it was that they both use the standard Android 4.3 notification system. This is the system that was introduced in 4.3. And they actually hinted at what they were going to do back in 4.3 was released. And if anyone paid attention, they allowed you to stream notifications to a remote device, like via Bluetooth. They even said it. So that's Android Wear being announced back when 4.3 was released. Anyway, the Android smartwatch was using that mechanism. So it's very similar frameworks that people were thinking along the same lines. Obviously, there were some limitations. I couldn't really get all the communication working because I couldn't do Google services and stuff like that. But I managed enough to be able to run apps locally on it and mimic the whole notifications to the watch. All right, so back to Android Wear. So now I'm able to fast OEM unlock the LG watch. But for those who haven't seen Android Wear, let me just put it up here. So this is the LG watch that's been flashed. Where was I? Let me jump ahead to... Oh, and the interesting thing is that after I unlocked it, I was still able to get an over-the-air update to the latest version. So it's actually safe to keep it unlocked and get updates. What's not safe is to keep it rooted. So that's why I don't recommend always keeping it rooted anyway. Just do ADB root. When you need root, that's when you should use it. So that makes it easier to get an OTA without any issues. Although I have to test it first and see if it really breaks if I root it and the OTA happens. Okay, so that was easy with Google Glass because they gave me a rooted image. Yes, but you're not going to have that's not the case right now with Android Wear. I can't easily root these by asking Google, can you give me the rooted boot image? So what a lot of people do generally is they try to look for exploits, but of course a lot of them get closed out very quickly, and right now there's no exploit in 4.4W or L that I'm aware of. Actually, I did read someone on Windows managed to create an exploit that roots your Android Wear, but that's the only one case I've seen. But in general, what rooting consists of is just editing the default prop file in the boot image's RAM disk. Now, what does that mean? So each one of these partitions you can boot from, and when you boot from the boot image, in addition to having the kernel code, it also has a RAM disk where all the configuration and file settings are. This default.prop file, let me see if I have it here somewhere. Let me just jump to what this is. These are just flags that tell it if you want to boot up as roots or if you want to be able to do ADB roots. So those are the combinations, and those are the only two flags that you need to edit in that file to root a device. But of course, it's a chicken and egg thing, so how do you edit that file if it's read-only? So you have to actually, the general procedure that hackers use to basically extract the boot image from the device so you can start editing it and then flash it back is a bunch of commands that will outline the partition size and it's a little complex if you really dig into it, but and this is a very simplified version. I've tried to do this on the LG, and all the names are like kind of obfuscated, so I don't know which partition is which. I can do a trial and error until I finally get it right, and that's probably what I'm going to do because I haven't finished doing this. But generally, that's what you do. You extract the boot image, and once you have the boot image, there are a lot of tools you can use to extract the kernel part and the RAM disk. Once you have the RAM disk and you extract the RAM disk, you can edit this file, and then you can, I was going to say, generally a lot of people like to put it back together to a boot image, but you don't have to. Fastboot has a command that lets you flash the kernel and the RAM disk at the same time as separate files. Because it's a little difficult to actually combine them again because you have to know all these numbers you saw before. But you don't have to worry if you simply do flash boot flashed :raw, the kernel, which is usually called Z-image, and the RAM disk, which is what we saw earlier here, this init RAM-fs. But that's really going into a lot of detail, which I know a lot of you may not understand. But what I really want to focus on is some ideas of again, experiment and learn, and what you can do once you have the privilege to run apps in the same level as the system default APKs. Now there's a place where you can place APKs in the Android called system/private apps, and generally apps that are installed there are preloaded apps that have higher raised permissions. So there's a lot of permissions that are not accessible to average Android developers. They're only used by system APKs. You can now have access to that by placing your APK in that folder, so that when you start up, you can have your own custom system service that manages things. And at the very least, what beginners do is the first thing they do is they customize the boot animation. So it's like a badge of honor to be able to root a device, change the animation on boot. But what I want to talk about is new interfaces, new gestures that you can do. So recently I managed to get the Mayo armband, which I'm wearing right now. It's a Bluetooth armband, and what I want to I'm going to do a demo of an application that runs on glass. So I'm going to go back to showing you glass. Where am I? Let's switch back to glass. And that's what that app was that kept popping up. Because it connects, I already paired with it, and it connects so I can control glass with my gestures in my arm. So, I mean, make sure I select the right one. What else do I have running? No, it's the only instance. So it's not... Maybe that helps. All right, I'm going to close it and start it up again. And this will be my closing demo. We can do Q&A right after it. I just want to show you this demo to really inspire you. It's just run this. So again, this is an open source screen capture program that lets you, it's nice for making presentations. I just have to remember which device is which. I think what I'll do is disconnect the watch. We don't need to look at that anymore. Try this again. Oh great, that's glass. There we go. All right, so, okay, glass. Show me a demo. So let me first make sure it's working by pairing. Usually there's Mayo requires a gesture that does this and this, and I'm not feeling it buzz telling me that it's working. So it's now, of course, demo fail. Actually, let me try pairing again. So maybe that'll do it. Pair. So there's libraries that Mayo provides that you use, and it does the pairing. You don't have to worry about that code. Or maybe you should. Maybe we got to hack their code. Yeah, so it's not working. So the idea is when I wave right, it goes to the next one. When I'm on the second screen, I can go left or right. And I can go to the last one and then just go back left. And the idea is also to, when I do a fist, it selects the menu, and then to swipe down or go back, I just open my fingers. So this was working right before I entered here. And of course, let me see. So these gestures work within your app, within your activity. So what I'm trying to inspire is, what if we made this work for the whole system? So the whole system navigation, instead of having to do this or say, okay, glass, I could be more discreet and do gestures down here, and you wouldn't know I'm actually controlling and browsing the web on glass. So that's what I mean by alternate interfaces, and we can play around not just with input devices, we can play around with how the UI looks and start experimenting more. Because to be honest with you, I think glass has become stagnant in the development community because it's been behind the Android versions, and there's been a lot of issues with jumping to KitKat. And of course, we'll have to wait and see when they jump to L. So while we're waiting for all this, we can experiment a little. We can void our warranty if you're okay with risking $1,500 and play around with some of the internals. So that's it. I'm going to keep trying to make this demo work. If you have any questions, feel free to ask. How many plan to get glass? How many plan to get Android Wear? Right. Why is that?
Cheaper.
Correct. So it's less of a risk to the fast boot OEM unlock on your Android Wear. So you can start playing around with alternate things, having things run differently or show differently. So it's a great time to experiment a little. If you're a seasoned developer, if you're a novice Android developer, I would not recommend doing this. But if you're seasoned, or if you know someone who's a hacker and you have ideas that you want to test out, it'd be great time to experiment. And hopefully Google will continue their obligation to AOSP and trying to keep things open. There's been a little closing of things into Google Play services. And of course, like I said, currently Glass is not really AOSP, and Android Wear so far isn't, although hopefully in the future they'll give you the ability to build your own ROM completely so it runs on an Android Wear watch. So what I'm going to do is try to exit this. I found some bugs with the Glass app where there's a number of instances that run. So hopefully I can, maybe that was the issue, that had too many instances running. Now I'm going to try pairing again. Wait. And this is another reason why you want to root Glass. In fact, let me show you that in a second. When you're in Eclipse, I mentioned this earlier, and you look at devices. So here you are. You can see all these, everything that's running. That's what's nice about having it rooted. And it's more easy to debug, and I can see if maybe there's a third-party app that's hogging resources and kill it, and so forth. So this is one good reason to root it. Even if you don't modify anything, the fact that you can run additional debug tools is a good reason. I'm going to just keep doing this. Oh, I got it. Wait. Wait, let me wake this up. Wave right, wave left. Notice it's getting heated because of the bug. All right, show demo. Let's try it again. Wave right. I lost it. You saw it work for a second there. I wanted to show the fist and the spreading of the fingers. All right, that's not working again. So there are bugs. I'm going to try to fix them and work with them. I talked to them recently, and I plan to put this on GitHub so that you can play with it. So let me just close out on my slides. Here's some resources. I will post these slides somewhere and soon. You can just find me on Google+. I also want to plug the New York City Google Developer Group that's meeting this Thursday. We're going to continue the Android theme. and have actually some guest speakers from this event and some that didn't speak at this event show up. So if you're local to New York, feel free to stop by NYC GDG. It's meetup.com/NYC GDG, and the details are going to be posted very soon. So thanks for coming.